-3 as we talk about now quadratic functions in standard form. Okay, standard form of a quadratic function, ax squared plus bx plus c equals y. And you've seen this before because it comes from the idea of just a trinomial quadratic function. What makes it quadratic? Boop, right there. When there's a 2 on top of the x, boop, it's quadratic automatically. Okay, we're going to skip this because I want to talk about how we can graph a quadratic function knowing two things, the y-intercept and the vertex, when it's in this format right here, and it's not hard at all. Okay, the first thing we need to talk about is the value of c, and the value of c is the y-intercept. Okay, whenever there's a number by itself without an x, that's where it's going to cross the y-axis. Boop, there's your y-intercept. Boop, there's your y-intercept. Boop, there's your y-intercept because of this, this, and this. That simple. How we get it? We plug in 0 for x. When I plug in 0 for x, f of 0 is the y-intercept. If you don't understand this, I'm going to take this stylus and I'm going to find the crayon in your nose to dig out the crayon out of your nose and your brain, because it's that simple. Goodness gracious. Okay. We use standard form of a quadratic function, okay? We need to find the axis of symmetry. It's very simple when it's in vertex form. It's not, I don't want to say it's not so simple in standard form. We can easily find it if we identify A and B, okay? To find the axis of symmetry, we use negative B over 2A, okay? Once we find out what A and B are, we plug those in. That tells us the axis of symmetry. As you know, that is the x value of the vertex. Once we find the x value of the vertex, we then plug it in to find the y value of the vertex, and then boom, we found the vertex, okay? Oh, sorry, it's right here. Actually, that's the vertex there, okay? So, at this point, once you graph the problem, we're actually good to go. Not asking you guys to be accurate, just as long as you're gonna identify both the vertex and the y-intercept as well as the axis of symmetry. It's actually not that bad. So here we go. Let's do this actually in a separate piece of paper. Okay, I'm going to pull out, oh, you just saw the answer key to a study guide of the quiz that I was working on. So let's do this. All right, let's pull out the question here. We're only going to do one, okay? X squared plus 2x plus 4, okay? So f of x equals x squared plus 2x plus 4, okay? The y-intercept's simple, okay? Right there. It's y equals 4. Very simple, okay? Now let's find the axis of symmetry, okay? This is our A, this is our B. Our A is 1, our B is 2. So that means x equals negative parentheses 2 over 2 times 1, which is going to be negative 2 over 2, which is negative 1. That is the x value of the vertex. Now let's find the y value of the vertex. So to find the y value of the vertex, I'm going to plug in negative 1 into here, okay? So f of negative 1 equals parentheses negative 1 squared plus 2 times negative 1 plus 4. When we solve this up, it's 1 minus 2, which is negative 1. Negative 1 plus 4, that's going to be 3. So that means my vertex is negative 1, comma 3. Let's graph it real quick, okay? So beep, bop, beep, bop, boop, bop, beep, beep, bop, beep, bop, boop, bop, and then beep, bop, beep, bop, beep, bop, and finally beep, bop, boop, bop, beep. Okay, so negative 1, 3 is your vertex, okay? It's right there. The axis of the y-intercept's right there, okay? To show the mirroring, we know another point's going to be over here, okay? And we know it's opening upward because your A is positive. So there's your graph right there. Knowing your vertex is right there, negative 1, 3, and the y-intercept crosses on the y-axis. Okay, there we go. Here we go. Okay. Noticing this now, remember that the vertex is the peak, okay? The trajectory of the water in fountain A is represented by a function in standard form, while the trajectory of the water in fountain B is represented by a table. We can easily find the vertex from a table, because if you notice these and these, notice how right there, they go from big to small. So your vertex is where it changes direction from big to small. Okay, we need to find the vertex of this. And how do we find the vertex? Well, again, we're going to use the negative b over 2a. Okay, we find the x value of the vertex. Negative b over 2a, our b is 2, our a is negative 1, boop, it's 1. We plug it in to find the y value of the vertex, boop, it's 9. So the vertex for this is 9, the vertex for this is 10. So the second fountain, or fountain B, is higher than the first fountain. Okay, got it there. Okay, so now let's compare this. Okay, we're going to compare this with this function. Okay, the vertex for this, okay, is 3, 0. Now let's find the vertex for this. Okay, and I'll put this over here. X equals negative parentheses negative 0.6 over 2 times negative 0.3. Okay, if we were to do the math, okay, let's actually do the math real quick. Let's again use Desmos. Okay, negative parentheses negative 0.6 divided by 2 times negative 0.3. Oops, negative 0.3. There we go. It's going to be negative 1. Okay, so it's negative 1. Now let's find the y value of the vertex by plugging it in. Okay, y equals negative 0.3, negative 1 squared minus 0.6 times negative 1 minus 0.2. We can use Desmos to find this also. So let's do it. Okay, so it's going to be negative 0.3. Oops, 0.3 times negative 1 squared, okay, minus 0.6 times negative 1, and then minus 0.2, okay? So it looks like that vertex, if I check here, yep, it's going to be 0.1. So when you equal that, it's 0.1. So that means my vertex is negative 1, 0.1. This one is higher because it's higher than 0. Okay, got that there. Last example. Mia tosses a ball to her dog. The function is given to you here. What does the vertex form of the function tell you? Well, it tells you the height of the ball, the highest part of the ball at X amount of time. And notice how when X is 2, that's when it reaches the peak. And the peak looks like it's going to be 8. Okay? What does the standard form of a function tell you about the situation? Well, it tells you where it starts. Okay? Notice how the ball started 6 feet high from the ground. Once we expanded it from here to here. Okay? Boop, we got that there. Okay? Let's look at this here. Suppose the path of the ball in example 4 is this. Find the initial and maximum height. Well, the maximum height comes from the vertex. Okay? So vertex 1, 6.25. There you go. There's your maximum height. Now let's find the y-intercept. And actually, we can do it without even using the standard form. Just plug in 0 for x. Okay? Negative 0.25 multiplied by 0 minus 1 squared plus 6.25. If we use Desmos to find that answer, let's do it. Okay? Boop. So negative 0.25, 0 minus 1 squared plus 6.25. There you go. It is 6. That's the final answer. Boop. So it's going to be 6. There's your y-intercept. Not a hard lesson. Not a hard lesson at all. Okay? Definitely look at the examples and all that fun stuff. Okay? Last lesson coming up.